Hi and welcome to an HCI presentation for the There You Are concept. I'm Marcus Ford, and we're going to take you through everything about this from the use cases through the technology that we're looking to use. So let's get right into it. Now think about this for a minute. We might know where someone is and be able to reach out and communicate with them. But as they move around and change their location, where are they? We may lose contact, and that's going to really cause some problems, especially if there's an emergency that comes up. What we need to be able to say is, there you are. There are a number of approaches, alternatives to our plan, which users can certainly take advantage of. But we see a number of shortcomings to these approaches, and I'd like to just go through some of those alternatives with you briefly here. One of those is to use a smartphone app of some kind. But that's going to require an expensive piece of technology. It's going to be expensive either for the user or for the organization if you're trying to outfit a number of people. And really, you're going to have that piece of technology with you if you're going to be able to communicate. And if somebody has a damaged smartphone or they forgot theirs at home that day, it's really going to make them a much less effective member of the team. There's also a wall-mounted iPad, but that's a waste of some really expensive technology there. There's also analog or voice, just calling around, asking where people are, communicating that way, but that takes the focus off of everybody's work and makes the organization less efficient. Now, Google Docs is certainly an alternative here, and it's used in a lot of cases like this, either in Google Calendar or a spreadsheet. But if somebody's headed out the door and they have forgot to update the spreadsheet on where they're going or what their status is, they've got to stop, they've got to pull out that device and go in, find Google Docs, find the right place, and then complete that updating process. Now, if they're late, if they're just not focused on it in the moment, they're just going to say, you know what, I don't have time for this, and they're going to walk out that door. And now that Google Doc is not as helpful as it could be because it's not entirely accurate. We have a couple of other alternatives here, and they both involve whiteboards. One of them is an analog whiteboard. This is just a traditional whiteboard that you see on the office wall, and it's cheap, it's there, it's easy to use, it's pretty effective, but the major downside here is that you can only see the location information for one location. As soon as you have two or more locations, you're not able to reach out from the second location in order to update the information on that whiteboard, and so it loses some of its effectiveness. A digital whiteboard may be able to compensate for some of that, but you're really looking at a very expensive resource that you're only using for a fraction of what it's capable of doing. So that's not a good return on investment for that solution. No, none of those solutions are really going to do what users need. So let's take a look at what those solution requirements should be. Really, there should be no personal device involved. You shouldn't have to bring your technology with you in order to participate in this exchange of information. It should indicate the location without people having to unpack stuff or go and pick up some kind of device in order to log in or do anything like that. It should clearly indicate the location without any text so that we've got some flexibility there across cultures, across different demographics. It should also allow one unit to communicate with units in other locations so that we can see the status of a particular person in all of the locations that might need to know where that person is currently. Lastly, the solution needs to be scalable. Scalable for an increasing number of people and scalable for an increasing number of locations. So here's our solution. Let's talk a little bit about the design of this. It's a box. It has 4 lights: blue, green, red, and yellow from left to right. Just to the left of the blue light, there's a space for the name of a person, and this thing connects to the existing Wi-Fi network in the room. Now, each one of these lights is not just a light, but it's also a button. So pressing the button changes the information that the light is representing. The state of the light is dependent on the pushing of the button. So if I, in this example that I'm showing here, am looking at the blue button, and if it's starting from the off position, which would indicate that the person is not in the blue location, whichever location we decide is going to be represented by that blue light. If I push that button once, it will cause the light, because it's a lighted button, to begin blinking, and this indicates that the person is on their way to that blue location. If I press the button a second time, now the light is on constantly, indicating that the person is currently located at that location. And if I push that button one more time, I come back to that off state. It's very important for any design to follow what are called universal design principles, and our project is no exception. Here are some of the ways that we look to bring in those core elements of universal design. One is called a multimodal interface. So we don't want to present information that's going to overwhelm a user, but we also want to bring in information that's kind of hitting all the senses. And so that's what we find here. The information is presented through the lighted buttons, and that's a visual input. It's also presented through an audio input, in that as the button is pushed, a speaker plays what we might think of as ear cons, kind of the flip side of an icon, and that sound has 2 parts to it. One is a part of the sound that indicates the location, so which button is being pushed, and the other part of the sound is what the new state is, whether it's off, blinking, or on. There's also an issue that we needed to overcome for folks with visual issues, because we can present them with the audio cues which help them understand what is happening with this system, but we need to also be able to distinguish between the different buttons, because the colors don't really matter in that way. So we found that there is basically the equivalent of a label maker that will create braille labels, and the surface of these buttons is completely flat. So we're looking to generate braille labels that will stick over the face of the button, and therefore uh, people who are blind are able to read the location information on the face of the button. In speaking to the visual modality and the auditory modality, we also want to speak to that sense of touch, what we would think of as haptics. And this is something that we're leaving out of the design for right now, because this is, in its current generation, designed to be something that is perhaps wall mounted or sits on a desk. And the haptic piece is not going to be quite as strong a design consideration. But with any good user interface, there is always the opportunity to expand it beyond its original intent. And we do see that as a strength in our design, is that we can branch out into some new areas in a version 2 and a version 3. One of those may be a wearable device, at which time a haptic component would make a lot of sense, and we would look to bring in this modality at that time. Next, I'd like to talk a little bit about some of the benefits of this design and the approach that we have for coming up with this solution. Because there are no words, because this is not a text-based interface, it can be used with any language. It can be used with folks who might have developmental disabilities. It's very simple, very clean in its approach. We're also using digital fabrication techniques, specifically 3D printing, in the assembly and modification of the unit. So this means that we can do a lot of prototyping, and we can also come up with some new approaches and maybe even some customizations for individual users. This simplicity of design, this capability to rapidly prototype and bring different variations to market, means that the user gets a very simple, easy to use interface that's incredibly powerful. Another part of what makes this so powerful is its scalability, which is a really important thing. So in this slide, what we're showing is that we have a number of units, 3 units, and each one of them shows the location of an individual person. We see these persona characterizations off to the left, each one linked to one of the 3 units. We also see that the 3 units will stack on top of each other, and this shows that we can not only scale up in terms of the number of people, but we can also scale up in terms of the number of locations. Speaking of locations, here's a slide just as a reminder that these are a number of units that are talking to each other. So in this representation, I'm looking at 5 units that would represent 5 different locations, and I see that the blue light is on each of these units. That indicates that the person being represented by that unit is in the blue location. So if I'm sitting anywhere in those 5 different locations, I know exactly where that person is. Having brought you through some of the details on our approach, we'd now like to take you through a use case scenario. There's a lot of different ways that this can be implemented, and this slide really is meant to show that. Here we have 4 separate personas: a mom, a dad, a sister, a brother. We've also got listed a number of locations: home, work, school. So these people are all going to be interested to know who's in what location. Is mom still at work? Has dad arrived at home? Is the sister still at school? Is the brother in transit from one building to another? But really what it comes down to is something much simpler. I say that because it's really one basic use case. It's about a location and transitioning between locations. So we're going to start at one location. We're going to indicate a location change, at which time we're going to be in transit to that second location. Then we're going to arrive at that second location. So let me walk you through this very basic user experience. Here we have the first step, which is leaving a location. We see our user here at the first house, which we're identifying here with a blue dot as the location for the blue light. In the distance, we can see a second house with a green dot. That's the location that we're going to identify with the green light. And we see that our user is currently at the blue house. In the lower right of the slide, we can see our device with a couple of sort of callouts, and we see that the state of the blue light is on solid because we are currently at the blue location, and the green light is off because we are not at the green location. Next, we'll switch to our transition location. We see our user is on the path between the blue location and the green location, and we see that the device itself, the lighted buttons have changed. The blue light is no longer lit, and the green light is flashing, indicating our user is on their way to that green location. Now here's our final state. Our user has arrived at the green location. We can see the user picture there next to the house identified with the green dot. And in the lower right, our representation of the device shows that the blue light is off and the green light is on, indicating that our user is currently at the green location. Now we'd like to take you through some of the technology that we are going to use to implement this solution. First, let's look at the components involved. The case unit is going to be generated on a 3D printer using 3D design software. This is going to give us a lot of flexibility. It's going to use a microcontroller, specifically the Feather Huzzah from Adafruit, because it has a Wi-Fi antenna built in. And we're also going to use 30 millimeter illuminated push button switches. These are devices with 4 leads. So 2 of those leads are going to handle the switch part, and 2 of those leads are going to handle the lighting of the switch. And of course, we will also have a battery on board. Having looked at the hardware, now let's look at the software. First, we want to look at the network topology. There are going to be devices that are talking through those feather boards with their Wi-Fi to a Wi-Fi router, and these signals are going to be sent to a LAMP or MAMP server. And really the key component here is the MySQL database. That's what's going to be collecting the information from these individual units and then sending it back out again so that they can display the state of our users. The architecture is just as important, and this is what we're looking at this time to actually do our development work. We're looking at C++, maybe some Python. We're still kind of looking at that one, but C++ can be done in the Arduino IDE, which will talk to the Feather Huzzah board. So that's all stuff that's been around for a while, and there are a bunch of people with experience with these tools. And that code that's going to reside on the Feather Huzzah board will be interfacing with the MySQL database. Here is our approach to that communication. The string which will be transmitted to the MySQL database. We're looking at something that is a piece of intelligent coding. So at least at this initial stage, we're looking at that code having 4 characters. The first one being an indicator of the person, that user that we're tracking. The second one is the module, that's the individual device in a particular place. The third one is the location, which button is being illuminated, blue, red, green, yellow. And the fourth position is the button state. Is it off, is it flashing, or is it on? Lastly, we'd like to share our next steps. This is how we're going to actually go and implement this design. We're very excited about it. This is something that is certainly a design project, but it's also something that's going to become something in real life. And so at this point, the parts have been ordered. They're sitting in boxes. We have a 3D printer that's going to be loaned to the project, so we can get started with that. We're really looking for this work to take off in this summer, the summer of 2017, and we're looking at a usable prototype by the fall. So we're looking for folks who would like to join the project. And if you have an interest in this, we'd love to hear from you. I'm Marcus Ford, and thank you very much for being with us. Oh yeah, before I forget, gotta get in a couple of shout outs here. One is to my daughter Aiden, who did our illustrations for the user experience. And also, we brought in some product photos from adafruit.com, which is where we've purchased the Feather Huzzah boards and the buttons from. So, both great resources right there.